Hi, this is Charlie, and I'm a drive and motor specialist. And today we're going to talk a little bit for the Smart Box on items that people don't always think of when they buy a VFD, and that's the cable between the motor and the VFD. Typically people think it's just like a cross-the-line starter, so why does it matter? Well, the cross-the-line starter, we have 60 hertz, whereas with VFDs we have very high frequencies there, so we need to do things to contain that high frequency energy. Usually what people come up with is, well, what do we do? How do we prevent all of the electrical noise from being transmitted into other items? And the next thing normally that comes up is how do we handle the higher voltages? Some are aware that there's going to be maybe 1300 volts on those lines because of the spikes that are involved. So to address some of those things, the VFD cable, which will be in the Smart Box for you to take a look at, the first thing being the shield. So we've got a couple of different shields here. We have a braid on the outside, and we also have a foil on the inside of that. Both of those work together to contain all the noise that the cable's generating and keep it from radiating out into other areas of your plant. The next thing we look at then is the insulation thickness. It's going to be hard to see from this sample, but the insulation on each of these conductors is much thicker than your standard THHN insulation. So therefore it handles those high voltage spikes, those possibly 12 to 1600 volt spikes, and does a good job of preventing breakdown in your insulation. Now also, along with your VFD cable, you're going to find that you have a very symmetric design. So with that thicker insulation, with the fillers that you see between each of the conductors, it's going to space each of those conductors very uniformly throughout the cable. Therefore, you don't get close areas or areas with thin insulation where you might get crosstalk from one conductor to the next, from phase to phase. Furthermore, another thing with the shield on the outside, you don't get crosstalk from one cable to the next if they're laid in a cable tray. All of the energy for one particular motor from a drive is contained within one cable. With the symmetrical design of the cable, you get less cable charging for long lengths of cable. When you have the high frequency energy and you have a long cable length, you can have a lot of charging just to charge the capacitance of the cable. But again, the thicker our insulation, the better it is symmetrically laid out there, evenly spaced, the less capacitive coupling you're going to have and the less charging you're going to have in that cable. Another great benefit of the VFD cable that we don't have with the traditional THHN cable, and you probably won't be able to see it, but we have a very fine strand on each of the conductors. So a fine strand, of course, is going to help with flexibility of the cable. It's also going to help with a phenomenon called skin effect. Skin effect occurs at high frequencies, which again, that's what we're dealing with the VFDs. So the phenomenon with that, which is a principle of physics, is the high frequency, the higher the frequency being transmitted over the conductor, the more that migrates to the outer skin of each conductor. So therefore, the more strands you add, the more capability it has to transfer that high frequency. You'll see also we have a drain that's attached physically. You'll also notice that it has a ground in the cable, which is the same size, same gauge as the other three phases. This is up to 3 times larger than what's required by the NEC for grounding. It's very important because your drive is also going to produce common mode noise, which will be transmitted down the line to the motor. It has to find a path back. So having a fine, high strand count, a large ground conductor helps to ensure that all of that common mode energy comes back to the drive through the cable rather than through your ground system of your plant. THHN cable absorbs moisture, and this is actually a THHN jacket on the outside, but it's not the jacket they're using here. This is an XLPE, which is resistant to moisture. So in a THHN, they absorb moisture, especially in your high moisture areas, your washdown areas. Once you get that moisture in there, the insulation quality degrades And now your insulation starts to break down with the high voltage, and then you get a little carbonized path that shorts you from phase to phase, and then it burns through, and now you've got to shorten your cable.
Yeah.
So that's one thing for moist areas. I'd say THHN absorbs moisture. It's not good. The other thing, in areas with sensitive equipment, I say all the high frequency in here needs to be contained. So therefore, if you don't have the shielding and you don't have a way to pull that back off the shield, all that energy is going to radiate out into your facility and cause issues. Just the return path, having that ground is very important. If they don't have that, that's when we start to see motor bearings go out, because there's just no path for that current to go back to the drive. So it goes through the bearing, goes back through the earth ground, finds its way back through your system, and now you've got noise on your entire system.
It's like the biggest pushback. Like why customers wouldn't use VFD.
I think the biggest pushback is we've already got cable in place, we haven't had any problems, so we're going to leave it in there. However, once we put a VFD on cable, it stresses and exercises that cable much more than a across-the-line starter did. So we may not have had problems before because it was low frequency power that was going through it, so there were no problems. But as soon as we throw the high frequency onto there, now we start to see cable breakdown, or now we see the effects of moisture getting into the conductors. And people are afraid of cost. Quite honestly, we quoted a customer just the last week a VFD cable versus what their spec called for, an armored cable with a steel armor jacket around it for durability. The VFD cable was actually lower cost than the armored cable. And most people say that's got to be so expensive. Well, one reason it is because of that ground being so thick. There's so much more copper in the ground alone and so much other more technology that it's going to cost more. But you can pay for it now, or you can fight later trying to find the problems caused by not having the VFD cable.